Hello everyone, welcome to today's video. Right now I'll be showing you a new rule in calculus, and its name is the product rule. So it's quite quintessential to differential calculus really, and it's quite a simple rule, so I thought it would be good to teach you this as your second kind of rule after the power rule, which is the absolutely most fundamental kind of rule in calculus. So now we're just going to dive into it, and without further ado, let's start. But first of all, I just have a quick note here. So when I prepared this sheet, I did not notice that you guys don't know the chain rule, or presumably don't know the chain rule yet. So I'm just going to say for this, just without the chain rule, which we'll discuss in like 2 videos from here, just kind of stick to this following rule here. So if you differentiate e to the k x, that will become k times e to the kx, and for integration, it's just the opposite. For e to the kx, you get 1 over k times e to the kx. Okay, so without further ado, now for real, let's start. So what does the product rule say? I thought it would be a bit irrelevant to include a formal proof, but I do think that it's good to have to get some practice with the thing. So just me showing you that it's equal to a function that consists of a product of f of x times g of x is equal to f of x times g prime of x plus f prime of x times g of x. Doesn't say too much, so I'm just gonna kind of show you what it actually means. So for here in this example, we have 2 functions timed by each other. And by the way, those 2 functions can be anything, just like here. We've got a very simple function, but it can be expressed as a product. So that is, we can say f of x, this 3x, and e to the 2x is g of x, we can say. And it's kind of commutative. You can choose your functions, you can choose your f of x and your g of x in differentiation, and there shouldn't be any problem if you get them the other way around. Something which I can't say about integration, but I'll leave it till the integration kind of sub-series. So what we do here is, what I often do is, I kind of make like an imaginary table in my head, and then, by the way, this notation here is the derivative operator. So whilst this means the derivative of y with respect to x, this means like an operator which you can actually apply to any expression, not just y. Just like you might have that, which is very long, and something like that, or f prime of x. So those are all really different notations, which all basically mean the same thing. And you also have d. Okay, so I hope I haven't confused you too much. But yeah, if you apply the derivative operator to f of x, what did we say we get? We said that for any ax to the power of n, the derivative will be an x to the n minus 1, right? So then what do we have here? What we have here is we have 3 essentially times 1, and then times x to the power of 1 minus 1. So 3 times x to the 0, which equals 3 times 1, so that's 3. And really, generally, you get used to it. You don't need to apply the chain rule, the power rule every time you do a basic kind of nomial. So you'll get used to it. You just remember how to do it. You don't have to kind of recall this formula every time you do that. You just know that if you have a number times x, we know that we just get rid of the x, and that's how we differentiate it. So I'm just going to show you that then we have 3 here, on the differential side, the derivative, it's the same thing. And g of x, we said that, well, it doesn't mean anything to you right now, but e to the power of kx differentiates to k times what we started with. So then that means we end up with 2 times e to the 2x. So what is this product rule meaning here? What does it mean? All we have to do is just kind of play around, kind of cross multiply. So then f of x is, 3x, and g of x is e to the 2x. You just cross multiply. Have fun. It's really easy. It really is that easy. So so what we end up with is 3x times 2e2x, that plus, and that's it. Like, that actually is. We can simplify it, of course, and then we get so we can get plus 3 e to the 2x, and of course you can simplify that to get 3 e to, like that, and then of course 2x plus 1, but that's just a matter of style. I'm sure in most calculus exams you'll be given the marks for doing that. Okay, so that's done. And now what do we have here? This can be expressed like a regular kind of quadratic, really. It doesn't have to be necessarily this way, but what I'm trying to show you is that the product rule holds for every product. So it doesn't really matter if there's a simpler way of doing it. We're showing that the product rule works. It doesn't necessarily have to be the way that's the easiest way of doing it. So let's just do the same trick here. So we have a function. Both are really similar functions, so this might be quite disappointing. Then we have our derivative operator in this row, namely. And we know that any constant just disappears in differentiation because, as you know, if you visualize a graph that's described as follows: y equals 6, so y equals whatever, y can even equal 1000, it doesn't matter. What it implies is that you just have a horizontal kind of straight line, and that means that there's no rate of change, because if it's just a line that doesn't change, then there's no rate of change, so the rate of change is equal to 0. So 5 doesn't matter here, nor does the 3 here, and x is just 1. So that's easy. So essentially what we get here is, quite interestingly, we just get this plus this. So we get x plus 5 plus x plus 3. I hope I'm not making a silly mistake here. Yeah, so that's just this. So that's our derivative here for the expression, for this expression. Oh, it's a minus, lol. Okay, so then it's 2. I don't know why I didn't notice, but okay. Yeah, okay, so x minus 2 here, minus 3, and then we have what we got just right now. Okay. And now to the last one, which is really easy. Really, you don't need any product rule here. It's just, you can just remove the x and that's your answer. But I'm just going to show you that it applies to every product where you have two functions. So that is. So you can just be a bit a bit ridiculous here really and say that this here is one function and this is another function, and then you can kind of get used to doing it in your head, and that definitely helps with your calculus skills. You know that this is a constant, so it differentiates to 0, and we know that this differentiates to 1. So again, we cross multiply. So what's 0 times g of x? Doesn't matter, it's going to be 0 regardless of what g of x is. And what is 1 times f of x? Well, that's just f of x. So then what do we end up having? We end up having f of x times 1 plus 0 times g of x. And then what we have is just f of x, so it's 9999. Okay. So I hope you enjoyed this video, and yeah, the next video will be about the quotient rule, which isn't as intuitive, I guess, for beginners, but again, my goal here is to show that really none of the kind of 3 elementary rules in differential calculus are hard, so that's product rule, quotient rule, and chain rule. The product rule, the power rule is too basic to be on that list, because people just kind of remember it and there's no need to kind of revisit it, I guess. So yeah, I'll just kind of continue from here with the quotient rule and the chain rule. Possibly make a video about trigonometric derivatives, because I feel like I'm kind of neglecting them here. So I'll just show you what they are, and yeah, see you in the next video.